Now we're going to look at a type of probability called conditional probability. So what is that? It's the probability that an event occurs given that another event occurs. So you know something's going to happen. How does that change the probability for the other thing to happen? Here's my example. If you know a point is in the circle, so now I know it didn't just land in the rectangle, it's landing in the circle, what is the probability it will be in the square at the same time? So I can kind of reason this one out. I know that it's in this yellow area. So the question is, what probability is it that it'll be landing right in there? Well, this is a pretty nice drawing. I can tell this is 1/4 of the circle. So the probability is 1/4. Now, I'm going to calculate the ratio of the probability that the point is in the square and the circle at the same time and divide it by the probability of the circle and show why that is equivalent to the probability it'll be in the square given that it's in the circle. I know that sounds like a lot. So first of all, let's go ahead. Probability that it's in the square and the circle, we had calculated this earlier, is 0.06. The probability that it's in the circle is 0.24. So that actually simplifies to 1/4. Okay, so that is the same thing we got just with our reasoning. Why will this always work? Well, let me go ahead and go back to this. The probability that something is in the square and the circle at the same time is the area of the square and the circle over the total area. The probability that's in the circle is the area of the circle over the total area. Now, you know when you have two fractions that are divided, you can flip and multiply the second one. And so now I can just say area of the square and the circle, the intersection of that, over total area times the total area over area of the circle is the same as what we had before. And I can see that these two will cancel out. So that tells me that the probability that that it's going to be in the square and the circle divided by the probability of the circle is the same as just saying the area of the intersection over the area of the circle. Well, that's the same as saying the probability that it's going to be in the square given that it's in a circle. So will you have to do this derivation? No, but that's why this probability works, is these total areas are going to cancel out. In reality, it's like your circle becomes the new total area because you know it's in there. So this leads to the formula for conditional probability. You can say that the probability of A given B is equal to the probability of A and B, the intersection, all over the probability of B. So we'll apply this for one problem. This is an odd problem that I'm going to do for you, but I want to show you what happens in certain situations. So I'm going to say, what is the probability that a point will be in the trapezoid given that it is in the triangle? So I'm going to actually use the formula and we'll reason it out. So I need to find the probability that's going to be in the trapezoid and the triangle, and you already calculated that in your practice. And that was 0.083, hopefully. And we figured out the probability for the triangle. It was the same. When I put both those numbers in, I get 1, or 100%. Why do I get 1? Well, isn't the entire triangle in the trapezoid? So if I'm in the triangle, I know I have to be in the trapezoid. Here's another example where I'm really just going to use the formula. Miss Wu teaches Geometry and Algebra II, so the probability the student will get Miss Wu for geometry is 0.18. The probability that they'll have her for geometry and Algebra II is just 0.03 or 3%. What is the probability that a student will have Miss Wu for Algebra II if they had had her for geometry? So I'm going to use the formula. The probability of Algebra II given geometry is the probability of Algebra II and geometry divided by the probability of geometry. So the intersection is this 0.03 and geometry is 0.18. And I can actually simplify that to 1/6, or the decimal equivalent is 0.167. So the probability that a student will have Miss Wu for Algebra II if they had her for geometry is 1 in 6. Or 0.167 if I'm approximating. So for further reflection, Why is the probability that a point will be in a square, period, different than the probability that a point is in a square given that it's in a circle? When you narrow down the confines, when you make the total area smaller, that increases the probability. When will a conditional probability be 1? Well, if the area you narrowed it down only falls in the thing you're looking for, it will be 1.